Okay, we're ready for number 6. Net present value. More net present value. Now, I think you all know what it means, but just in case you don't, present value net of investment. Now, the idea, of course, is your investment is a downstroke, and then you hopefully get some positive cash flows out here in the future. And the idea is that the sum of these in a present value sense is more than the investment. And if that's the case, then you get a net present value equal, greater than 0, which is what you want. Now remember, these are expected. You don't really know what they're going to be. So the investment's usually known. This is not. And of course, the reason you have to discount these at a cost of capital is to compensate for risk. All right. And the time value of money. All right, we wrote last time that the value at period 1 of an asset is the value at period 0 multiplied by 1 plus the cost of capital. And that's pretty easy to see. Okay, say that this was worth 100 to start, and cost of capital is 1.1, cost of capital is 10%. You think then this is 1.1. You multiply the 2, you get 110. That would be your expectation that you would have at the end of period 1. And if you then decided to dividend out, so I seem funny say dividend out, just dividend works. If you'll dividend, say, 5, you'd have minus 5, then this would reduce to 105. Okay, so anyway you look at it, that's how it all works. Now, I'd like to solve for V0. So one of the easy ways to do that is just divide both sides by 1 plus k. I can do it here. You've got to do every term, of course. Dividend gets it 2. And then, of course, these guys cancel out. Then you can take this thing and move it over here, and then what you end up with is V0 equals dividend 1 divided by 1 plus k plus the value at end of period 1. 1 plus k. Now just remember, this is expected. You don't really know what this is. You know what if there's a stock market, you know what this is. Okay, that's just for one period. But now let's do another period. Let's try the period. We can go to period 1. So period 1 looks like this. We'll have dividend 2 divided by 1 plus k plus the value at the end of period 2 over 1 plus k. Now you can derive that or just get it from this formula. Now, what you want to do then is you want to substitute that in this equation. Now if you look at this, what I will do, and I'll just change color so you'll see how it works, is what I'll do is divide this by 1 plus k. And you see that's going to then look like this term. This term looks like that term. So if I do that, I get this squared, and I get this squared. And so now if I substitute this thing into this whole term here, then what I get is that, I'll just write here, V0 is first dividend over 1 plus k plus the second dividend, 1 plus k squared, plus the expected value at the end of period 2 over 1 plus k squared. And again, this is expected. All right. Now you can obviously just continue this out, and what you normally see is a formula that looks like this, only you'll see dot, 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 and then usually you'll see plus the value at the nth period, maybe 10, or divided by 1 plus k to the nth. And then if you keep on going forever, you'll see the dot, 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 and it just keeps on going. All right. Now, I can't tell you how many times I've done this sort of thing where n is 5. You take 5 years of cash flows and you discount them at the cost of capital, and then you have to do something about this value at the end of the period. Now, the end of the period, this thing is called the residual value. And that's a residual value at period n in this case. So if it's a residual value at period 5, then that's what it would be. But what you do is you have a way of calculating this, and we'll sort of get into that. But first, okay, I should have said one other thing. From an assumption standpoint, we're assuming that the cash flows are all at year end. Now, do they have to be at year end? Of course not. You can do them in the mid-year, you can spread them out, you can do continuous discounting and so forth. But I'd say 99% of the time when I've been doing these things, I've used year-end cash flows, and that gets you to your answer close enough. And of course, it's kind of conceptually nice because you think, well, I'm investing something, and then something happens a year later, and all the cash flows come streaming in a year later. If that's not the case, then you have to think about it a little bit more. Now, let's take a case. Let's move this up. Sorry, I was going the wrong way. Let's move this up where the cash flows go on forever. So what we have then is the value equals, we'll do it again, div 1 over 1 plus k plus so forth. Now we have dividends too. Now let's also assume that the dividends are the same. So div's the same. So here what you have is that your value is the dividend. It's going to be common all the time to 1 over 1 plus k plus 1 over 1 plus k squared plus ... Just keeps on going forever. All right. Now, you're probably ahead of me and you know what this is. The value of this, if you work it out, and you ought to be able to do this, is 1 over k. So the value then of this stream is the dividend over k. And obviously if k is 10%, then this is 10. If k is 5%, this is 1 over k is 20. So another way is you can think of it as the inverse of a multiplier. And a lot of people like to think that. They'll say, well, I get such a certain cash flow or a dividend, and then I'll multiply it by 20 or multiply by 30. That's where the earnings per share thing came about. So again, this is called a perpetuity. And one of the things that where it comes in mostly is in valuing this residual value. You'll find this happens a lot. We'll use this as a way of valuing this perpetuity. So Vn becomes whatever the cash flow that was there, and often it's net operating profit after tax, no PAT, divided by cost of capital. Of course, you then still have to divide by 1 plus k to the nth, so whatever it is. But if you do this, it seems like you're making some terribly aggressive assumptions. In some cases you are, but it works out quite well. And again, I've used it lots, and I always start there. Now, it might turn out that there's a better way to do it. You might have some growth in there, but I think what you're really trying to do, and we'll talk about this a little bit more, is to break the future into 2 periods. So if this is time, you have the forecast period, and you have then the residual value period. And here you say, I can beat the cost of capital. Here I cannot. I'm just going to make the cost of capital. That's all I'll be able to do. Okay, we're running out, so we'll continue this in Lecture 7.